this matter in terms of goals. What end goal do you want in learning? In learning generally, you want an A, you want a B, you want a C plus. Here we always aim for an A and an A of 84 points. That is the overall grade we aim at, because I believe we usually get students of 400 marks and above. I think the least mark we usually get is around 380. And of course, we also get students from the far-flung areas, the marginalized areas. We usually get students of marks as low as 350, and we transform those ones into A's. So I believe everyone has an ability, on condition they set clear goals on what they want. The other thing, after you have set goals, it's always important to know that these goals must be achieved. How do you achieve them? You must be disciplined. If you are not focused and disciplined in whatever you are doing, you may not be able to achieve whatever you want to achieve. So here, we value discipline. I'm sure you've seen in the media on how our boys usually behave. And me as a teacher, I can tell you, here in Kapsabet, we do a lot of focus on discipline. If the discipline of the student is not good, if a student cannot follow instructions, we
do a lot of instructions in chemistry. Look at the practicals we do, look at the experiments we do. We do a lot of instructions. So if you are not disciplined enough and focused, you may not be able to follow those instructions. So self-discipline must be adhered to in order for you to do well in sciences. You must also be focused, never lose concentration. Sometimes we may have so much to do within a short time, but whenever you are given an opportunity, whenever you are given a chance to be in a science class, always pay keen attention to the small details that are required. And of course, we also need you to know the main things that you are needed at the end of the day to do, so that you can be able to focus there. The other thing I want to talk about is ambition. You must be ambitious enough. You must be able to align that with your discipline, and of course, as always, you'll always make it. You'll always make it. In sciences, generally, you need to be curious. You need to be curious. Never allow any idea to pass you. You should be hungry to learn. You must have hunger for knowledge. Every aspect of school, every aspect of your subjects, and I want to really focus on what is on the table, chemistry. Any aspect in chemistry that comes by is not by mistake. It is by design. Right from Form 1 to Form 4. If you left any aspect or any concept in Form 1 that was highlighted, and sometimes in chemistry, there are specific areas I'll talk about later. I'll talk about those specific areas that I want you to pay keen attention as you move along in chemistry. But generally, I want to say that you must be hungry for information. Be hungry for information. Learn something new every time you get to learn. Learn something new. Challenge yourself to always do that. You must also have a plan. Plan your work. Chemistry is not a subject. Sciences generally. Let me talk about sciences. Even mathematics, even languages. You must develop a even when you are attending a lesson, there is always an objective to the lesson. So you must be able to get to know what are the objectives of the lesson. The other thing is this: be a problem solver. Be a problem solver. Okay? I know there are sometimes we complain about certain issues in life, in school or outside school. You complain about certain issues at home, some of which you can be able to design a better way of solving them. For us here in Kapsabet, we believe bringing our students on board in solving the problems that we face. So always have the mindset of a problem solver rather than a creator or a troublemaker. Always have the mindset of a problem solver. The other thing is, in becoming a problem solver, there are so many ways you can solve problems. You can solve problems formally. If it is a problem that has been identified and has certain ways of solving it, please stick to the manual of solving those problems. If you can't stick to the manual of solving those problems, you may need to consult. You may need to be a little bit more creative in solving those problems, as long as it does not infringe on the rights of other students, teachers, and even the school policy. Always stick to the school policy. I think that is something I forgot to mention. And now that I've mentioned, I think I'll move to the next point, which is closely related to that. Talking about being creative, sometimes you can be creative to an extent that you can bring interference in the system. I want to say that as a creative student, you should also be adaptive to the demands of the system you are under. If you are in a day school, be adaptive to the modalities that you have in school and outside school. The environment you are in may not be the same. So adapt to that kind of an environment and find better ways of dealing with that environment. You don't need to be to respond to every barking dog, but then respond to the ones that are relevant to you in that environment. Don't solve everything. Solve the issues that concern you. Some that do not concern you, don't mind about them. Be adaptive to the environment to the extent that you know what to pick in that environment. Others you are there to be ignored. So some issues in the environment may not be yours to solve. It may belong to someone else. So let everyone do their job or rather play their role in the environment you are in. That is in this case the school. And I'm talking about this one in the classroom environments. You may need to be more keen on what is happening. Do not focus much on what the other person has done. Focus more. for us here in Kapsabet, we focus more on what can you offer yourself. Have you given the other people the right environment to respond, or rather to treat you the way you want to be treated? That is part of being adaptive to the environment. You don't expect the others to greet you well if you yourself you cannot be able to be greeted, and you cannot greet others. You cannot interact well with the others if you are not ready to interact. You don't expect the others to serve you or to teach you chemistry if you are not teaching them biology. For example, if you are good in biology, you have to adapt and play your part, and look more at what you can offer rather than what you can be given. Of course, it's also important to know that you have to gain, but then how much can you also give? That's key. Closely related to that, we usually say be the change that you want to see. If you want a better grade in chemistry, it should begin with you. How much effort, what are you doing to ensure that chemistry is coming up? How much time are you allocating to chemistry in your timetable? How much effort are you putting in chemistry in terms of revision? How much are you putting in chemistry in terms of calculations? In terms of calculations, are you giving it time? Especially those in Form 3 and Form 4. There are several calculations involved in chemistry. I'll talk about that one later. How much energy are you putting in that thing that you want to see changing? If you are not putting any energy in it, stop talking about it. That's what we say. That's our policy here. If you want the flower bed to be good, don't be part of those who throw litter on the flower bed. I'm just giving an example. If you want your road to be clean, if you want your class to be clean, can you show the way to do it? Stop putting litter on the floor. Instead, you can encourage others to put litter on the dustbin. I mean, that could be an example of how you can be able to begin a change that can make you succeed, and the others, of course. Now, the other thing is accept and love your teachers. If your teacher, I know we are not all the same. I may present my lesson in a better manner that you can understand. Another teacher may present it in their own way. But at the end of the day, the goal is, are you able to get what we are teaching? So maintain a good rapport. Love your teachers and even classmates. Never judge them too harshly, and don't do those judgments. Of course, a good person will always be good, and the rogue ones will always come out. So it's not your work to bring out the bad in them. Instead, do a lot of bringing out. Look at the good in someone. Don't look at the bad things in people. Because if you focus on negative, we usually talk about negative energy begets negative outcomes. So if you do a lot of positive energy, you will get positive fruits. So do not focus much on the negatives that maybe your teachers have, your students, your classmates are having. Focus more on the positives. What can I get? What good can I get from this person? That's what we do. Personally, I do that. There are people sometimes that believe some students are not good. People like parents, sometimes a parent can tell you this boy is not like this and this. know your parents sometimes report you to us. But for me, when I do my interactions with students, I always see something good. I try to find something good to this person. What can I do to this person to make sure that he's encouraged in what he's doing? That's something I want you to also try. And the other thing is you communicate properly. Do good communication. If you have a challenge somewhere, don't hide or don't feel ashamed in identifying and coming out and saying the areas that you need to be a problem now, you'll solve a bigger problem later. So please, I want to encourage you to do that. Lastly, always believe in God. Sometimes if you feel like things are very hard, do a small prayer. I'm sure we are all religious. I don't want to say at this stage we have people who don't believe in God, but always believe in prayer. Sometimes things may not go your way, but it goes the nature's way. Even in chemistry, we believe that the things we are learning in chemistry are the things of nature. There is nothing much new we are discovering. We are only discovering the processes of how to get there. But otherwise, if sodium is supposed to react with water, it will always react. It's only us for us to know how does it react, what product does it give, But the other part is nature. So sometimes nature may not go the way you want, but you have to learn how do you redirect that nature, how do you harness the energy out of that nature to your benefit. So I want to talk about chemistry as a subject. Now chemistry has 5 topics in Form 1. I'm now actualizing what I've been talking about. Before you do anything, you map out your work. Don't walk blindly. Map out your work. Chemistry has 5 topics in Form 1. Out of the 5 topics, some topics begin and end at Form 1. Some will build up to other topics in Form 2, in Form 3, and Form 4. For example, I could tell you out of the 5 topics, Introduction to Chemistry, I could say it's just introduction, the way it is. It is the introduction. You are introduced to apparatus. You are introduced to maybe methods of separating mixtures, and a reminder of what you learned in your primary. And the other topic, simple classification of substances. That is an introduction to some of the supporting processes to the main reactions. In what we do mostly in classification is we are identifying these processes that are useful in reactions that we shall carry out later. For example, in chemical or physical changes, in chemical changes, there are processes that are used to separate substances. Those ones are in simple classification. In reactions, in chemical changes, there are processes that are useful, like filtration. We have processes like distillation, those ones are supporting processes to physical changes and chemical changes. Those ones are all classified under simple classification. And simple classification also gives you an opportunity to learn on how to explain phenomena around chemical changes and physical change and chemical and physical changes. Like when you are explaining something like a kinetic theory of matter. Kinetic theory of matter, you are basically explaining what happens in a physical change. When you are describing chemical symbols, when you are writing chemical symbols, when you are writing chemical equations, you are describing what happens in a chemical change. So basically, simple classification is about what with a chemical change, how to deal with a physical change. Now, of course, we have the other topics, acids, bases, and indicators. Those ones we have. This topic is very important. You need to get this topic very well, because this topic is the father of all the topics. Acids, bases, indicators. If you didn't get it in Form 1, you may need to go back a bit there, because this is the father of salts in Form 2. It is the father of the mole in Form 3. It is also the father of electrochemistry. It is also the father of acids, bases, and salts in Form 4. It's also the father of because we deal with energy changes, and these energy changes we shall be reacting substances around acids and bases. When we talk about neutralization, how much energy do we get out of a neutralization reaction? You see, it is still acids, bases. And this topic builds up slowly. Okay? Builds up slowly. So, we have the other topics now. We have the other topics, we have water and hydrogen. We have also air and combustion, water and hydrogen. So these ones are dealing with non-metals. Now we shall learn about several non-metals. Air and combustion deals with the first non-metal, oxygen. Do you know issues surrounding oxygen? Water deals with the second non-metal, hydrogen. Now, and in oxygen, I told you we need to map out things here. Hydrogen, what do you need to know about non-metals? These are the key things you need to know about non-metals. Number one, you need to know about the occurrence. How does oxygen occur? How do we get oxygen? How do we get oxygen? Occurrence, how does it occur? How do we get it? We study how we get it by talking about extraction. That means we are not extracting it from an ore. How do we prepare it? Extraction goes with preparation. How do we prepare oxygen? What are some of the physical and chemical properties? Physical and chemical properties of oxygen. We will talk about reactions of oxygen with other substances around there. Yeah. Then we look at the uses. How do you use oxygen? So those are the basic things you need to know about all the non-metals. Now I'll talk about Form 2. Form 2 has the following topics. It has a structure of the atom, and the periodic table. It has chemical families. It has structure and bonding. It has salts. It has effect of an electric current on substances. It has carbon and its compounds. Now, so the first two nonmetals were dealt with in Form 1. Then we have the next one nonmetal, which is carbon and its compounds, to be dealt with in Form 2. So between Form 1 and Form 2, you will have dealt with two nonmetals. Not two or three. Three nonmetals. You will have dealt with three nonmetals. And in each of them, when we are discussing chemical properties, let me just go back to chemical properties of nonmetals. For nonmetals, when we are discussing chemical properties, we have in every nonmetal an industrial process, a related industrial process. Which industrial process? You can have one or two, one industrial process or industrial processes in a nonmetal. Now, which are these industrial processes? An example I can give. What industrial process do we learn in carbon and its compounds? We have Solvay. We have Solvay process. Have an industrial process around carbon and its compounds. What industrial process do we have in oxygen? We have, some of them may not be studied under chemical properties. It may be studied under uses, like oxyacetylene is an industrial use of oxygen. So industrial processes can come in at the level of uses or at the level of chemical properties. Now, we have Form 3. Form 3, for those who are in Form 3 and Form 4, we have a continuation of the nonmetals. We have three nonmetals in Form 3. We have nitrogen and its compounds. We have sulfur and its compounds. We have chlorine and its compounds. The mode of studying these nonmetals is just the same. The occurrence, how do you extract or prepare, physical properties and chemical properties, uses. And then, beyond that, something else, it may have compounds. It has compounds. And most of these compounds are other gases. Now, that is where I want to focus on. In Form 3, you prepare how many gases? Under nitrogen, you prepare around 5 gases. You first of all prepare that nitrogen. You prepare nitrogen 1 oxide. You prepare nitrogen 4 oxide. You prepare ammonia. And in these preparations, we have a procedure. It could be 1 or 2. You need to pay keen attention on that one. And that procedure comes with a chemical reaction. That chemical reaction has a chemical equation. So you need to take note of a chemical equation of the chemical reaction that occurs to prepare a gas to prepare a certain substance in each of these nonmetals. Then, of course, in Form 3, we also have the other topics. We have gas laws. We have the mole. We have organic 1. And these topics of Form 3 usually a build-up of what you have learned previously in Form 2. Now, let me say this before I go to Form 4. Form 2, let's go back to Form 2. Form 2 is the beginning of real chemistry. I want to focus on the first 2 topics of chemistry. First 2 topics, structure of the atom and the periodic table. These are key topics in chemistry. Why I'm saying so is because if you look at the questions that usually come before or rather at the beginning of the chemistry paper, you are more likely to interact with things like draw the structure of the atom for an element that has atomic structure this, or that has atomic number like this, or mass number. Yeah. So I want you to focus on structure of the atom and the periodic table, chemical families. That's where chemistry also begins. That's where you learn to differentiate between one group of elements and the other. Okay? You learn to differentiate between one element and the other in groups. In what we call chemical families, we have 2 chemical families. We have groups and we have periods. At that point, that is where you learn to associate elements or dissociate elements. Look at what physical features do elements have in common? What physical features do they have different? What chemical aspects, what chemical properties do they have in common? What chemical properties do they have different? What could be the reason behind it? In chemistry, there is something I didn't say. In chemistry, we have an objective in anything we say. When I say sodium is more reactive, we don't just say there must be a reason for it. When I say sodium is more reactive than magnesium, I have to qualify that. What is the reason behind it? There must be a physical feature in sodium that makes it more reactive than magnesium. There must be a chemical feature in sodium that makes it more reactive than magnesium. So anything we say, any statement or any declaration we make must come with a reason. Now, talking about chemical families, that is where you begin explaining stuff in chemistry. You explain trends, you explain why size matters in reactions, why molecular mass matters in boiling and melting points. Yes. So there you get to explain the phenomena that are observed in elements. And of course, you explain, some of them you explain under the same family, or you explain from one family to the other. That is where we also learn to talk about uses of some of these elements. Now, in structure and bonding, that is now the other bigger area that you also need to focus, because that is where you explain more phenomena about the behavior and the properties of some of these substances. And structure and bonding will extend this beyond elements. You will now explain compounds. What makes this compound different from the other compound in terms of the physical properties? things like melting points, boiling points, electrical conductivity. How does the structure and bond affect these aspects? How does structure and bonding affect physical properties like melting points, So in structure and bonding, you need to explain. So in chemistry, we look at 4 things. 1, what is this substance made of? Yes. What constitutes a substance? 2, out of this constitution, what properties does it have? What physical properties does it have? What chemical properties does it have? Yes. 3, we now explain what makes it different from, based on the physical and the constitution, based on the constitution, on what makes it up to form either the compound or the molecule. What makes it different from the other one that is constituted by the other substances? We explain that, what makes it different from the other. And of course, the other thing we look at in chemistry is what use does it find having those properties? Because it is made of sodium and chlorine. What use does it get in nature? What use does it get in an industrial process? What use does it get in domestic in a domestic environment? Yes. So we look at the 4 aspects of any substance in chemistry. So non-metals are no exceptions. We have to involve that. Now in Form 4, we have 7 topics. We have energy changes. That is where I'll need more time to explain about it. We have rates, reaction rates. We have metals. We have organics too. We have electrochem. We have activity. Yeah. And we also have acids, bases, and salts. We have acids, bases, and salts. Now, in Form 4, you need to have been more organized in Form 3. In the Form 3 topics that, of course, organic, you need to have been organized from Organic 1 to be able to get Organic 2 properly. So Organic 1 must be taken in well for you to be able to get Organic 2. And most of these topics in Form 4 only require you to be a bit more keen. Otherwise, some of them may be a build-up of what was learned in Form 3, but then you can still begin afresh in Form 4 and be able to get some of them. But of course, some of them you need to have had enough knowledge, like acids, bases, and salts. You cannot begin learning acids, bases, salts in Form 4. You must have knowledge of Form 3, you must have knowledge of Form 2, and a bit of Form 1. So that's a wide topic that sometimes it looks very easy, but it forms the basis of so many things. It forms the basis of questions in Paper 1, basis of a whole question in Form Paper 2, and almost the entire questions in 2 questions in Paper 3, because we look at titration, it is acids and bases. We look at ions, those are acids, bases, and salts. So I need us to give more attention to acids, bases, and salts. That's not a mean topic, it is a wide topic. Of course, connecting that with the mole, because the mole, I believe it is a continuation of acids, bases, and salts. So I think I can now maybe highlight a few things you need to do in chemistry. Now that I've highlighted the topics that we have, and you may need to know some of the approaches, but I wish we get more time. But quickly, let me just highlight some things you need to know. Now, in chemistry, you need to always learn the main concepts. Learn the main concepts. Like, for example, let me just focus on a topic. Let me pick on what? Effect of an electric current. If you are dealing with effects of an electric current, look at the main concept there. What is the main concept? The main thing there is, how does an electric current affect other substances? And an electric current, the objective of an electric current is to be conducted. Can it be conducted by these substances we are talking about? And if not, why? So we explain the main concept. The second thing you need to know in chemistry is you must always know how to write a chemical equation, a balanced chemical equation. That one is not negotiable. If you cannot write a balanced chemical equation, my friend, life may be a bit difficult here, because in paper 1, for example, you will do so many balanced chemical equations, whether ionic or the ordinary chemical equations. Now, by the time you get to Form 3, in fact, after topic 2 of Form 2, when we ask you to write an equation, we don't intend you to write a word equation. We intend you to write a chemical equation and balance for that case. The other thing in chemistry, you need to know the following. If you are approaching a practical, you must do all calculations right. Calculations must be right. The mathematics of chemistry must be always right, because in paper 1 we have calculations, paper 2 we have a lot of calculations, paper 3 we have enough calculations. So calculations go right in hand with graphs. You must know how to draw a graph, whether a graph of an exothermic reaction or an endothermic reaction. Yeah. You must also be able to make observations. That is very important. You must be able to make observations. Without you making observations in chemistry, it might be very difficult to explain. And in addition to observations, after making observations are made so that they can be explained. So make observations. You must be able to make observations and explain those observations in chemistry. And then lastly, in chemistry, generally, we intend you to know practical applications of processes, substances, and even practical applications include things like uses. So, I believe I have captured the main things you need to know about chemistry. So, I will expound on the other extra things you may need to know in chemistry, and the main areas that I've highlighted. So because of time, I want to really appreciate your participation in this lesson, and I look forward to being with you some other time. Thank you. Maybe you can ask a few questions.
Thank you so much, President. An educative presentation.
Yeah, questions?
Stephen?
Pardon?
No, one
Oh yeah, it's okay, yeah. Okay.
Eva, if you can hear me, kindly say something.
No? Yeah, okay, you asked something about mindset. Maybe what I can suggest is you can type. Can you type the question there, down there? I wish to answer the question from Princess. Now, Princess is asking, she didn't understand the points around the mindset of a problem solver, and I want to respond this way. You will face so many challenges around learning chemistry and generally learning in school, okay? And sometimes you may have a suggestion. You may have a suggestion on how best a problem can be sorted out. Let me give an example. You could be having an issue around a few calculations in chemistry, okay? And you know very well that there is a student in your class. There is a student in your class who understands how to calculate some things or some problems or some questions in the subject or in the topic. You could as well suggest that the same student could guide the others in giving a solution to a certain problem in mathematics of the mathematics of chemistry. So I'm talking about that kind of mindset where instead of complaining that you do not have the ability to do calculations, for example, you may know a better person who can do it and maybe suggest to the class or the leadership of the class, maybe the subject teacher or the class representative, to allow that person who knows how to do a certain question to be able to do it for the others. So that is an example. We could have so many other situations that you could have a way of solving it. So you would rather suggest that to the people in charge so that they can be able to help. I believe Princess, have answered your question. Now there is another question here from Omar, and he's asking, how do you prepare for chemistry paper 3 as a candidate? Remember, paper 3 is a practical and it has 3 questions. Paper 3 has 3 questions. Question 1 is based on, we call it quantitative analysis. So this one, you will calculate a number of things there. You can calculate quantity of heat. You can calculate the moles, molar mass, and even the mass. Yeah, but most of the times you will calculate moles. You do titrations. You do the 4 different types of titrations. I believe you know. We have direct titration, we have indirect titration, we have back titration, and we have redox titration. So basically paper 3, maybe I'll need some time in the near future so that I can go through question 1. I believe that will sort you, Omar, soon. We might need to go through question 1 so that we look at the 4 types of titrations. You also prepare on energy changes. There are these calculations around the energy changes, the heat of solution, heat of neutralization, heat of combustion, heat of displacement. You know, you can be asked to add magnesium into a solution of sulfate. Magnesium will displace copper. Then you have to calculate how much displacement has been done. You know, you can be asked to heat ethanol. Then after some time you measure how much has been heated. You know, so that basically means you have to is inorganic. Question 2 is inorganic. When you are preparing for this one, you are basically testing for ions. You are testing for ions, which are in 2 categories. Kuna cations, positively charged ions, and we have the anions. Anions are negatively charged ions. So there is a procedure for testing for cations. There is a procedure for testing anions. And when we are testing these cations and anions, we test them and do elimination. We test by elimination method. You test using the general means, then you go to the specific tests that will distinguish one a cation from the other, one anion from the other. And question 3 is usually organic. Usually an organic question, organic chemistry. That question is usually the easiest one. I can deal with that one within half an hour. I'm done with that one. So I'm looking forward to looking at that in future soon. So for organic, let me just give a preview. When you are preparing for organic, you must ensure that you know all the organic substances. How to test for alkanes, alkenes, alkynes, alkanols, and alkanoic acids. Each one of them has a specific method of testing for the presence. So that's basically what happens. The same thing to cations, the same thing to anions for question 2. Each substance has a way of testing for the presence or absence. Okay. So Omar, I'll be able to deal with that one later when I'll sort out paper 3. Steve Mburi is asking, it's just a positive comment there that he's appraising us. Thank you, Mburi. Princess has asked something about creating and balancing chemical equations. Key things to note: 1, you need to identify the reactants and of course the possible products. That means what? You need to know what nature of reaction are you talking about? What nature of reactions are you intending to write the chemical equation? So you must know the reagents, you must know the reactants and the products. That one you have to know. You cannot balance, you cannot do anything before you know. Key things, know the nature of reaction you are dealing with. Because in Form 1, we have done so many types of reactions. We can react an acid and a base, you know the outcome. You get a salt and the water. When you are reacting a metal and an acid, you know the outcome is a salt and hydrogen gas. When you are reacting an acid and a base, you know the outcome, a salt and water. When you are reacting a metal and another salt, that ends up displacing one metal in solution from the other, there will be a displacement reaction. So the other thing to note is the number of atoms and the identities on the reactant side must be equal and identical to the product side. If you have 2 sodium on the left, let me use the example of what? Of sodium reacting with, let me just use sodium hydroxide with HCl. When you are reacting sodium hydroxide with HCl, you get sodium chloride and water. So the number of sodium on the left side must be equal to the number on the right side. Oxygen must be the same on the left, on the right. Hydrogen on the left must be equal to the hydrogen on the right. Yeah, I think that would be it. And then, of course, a balanced chemical equation must also come with the chemical state symbols. That is, sodium hydroxide, when you are reacting sodium hydroxide, it is in solution form, it is AQ. Water that is formed is liquid, so it must come with state symbols as well. Omar, any trends in setting chemistry, paper 1, paper 2, and paper 3? There are, I would not want to say trends, but rather there is a format. There is always a format that is followed in setting them, and if you have past KCSE papers for paper 1, paper 2, and paper 3, I'll be able to give us a few samples in the next lesson. But for now, take note that sometimes the next examiners can set a similar thing within 2 consecutive years. Sometimes they set different things. So we do not have a fixed trend, but rather the mode of setting is I can say is predictable in a way, because question 1 will always be quantitative. Question 2, no, it is inorganic. Question 3 is always that is for paper 3. Question 1 is always quantitative. So it can be energy changes, it can be crystallization, it can be titration. Question 2 is always about non-metals and metals, that is the cations and the anions. For question 3, it's always organic. So, in a way, that trend is usually maintained, Omar. So, I believe that is the much we can say for now, and I want to thank you very much for being in my class. And I wish that we do more of this, and I also want to encourage you to put into practice what we have discussed today, and always focus, maintain focus, never let anything go without your involvement. Make sure you're involved in every process that will make you or rather that will make a way into a good grade in your subjects. Thank you.
You have learned as well the students have learned. So we are so grateful that you have taken this chance to be with us, and I believe the students have learned a lot. So mine is to the students to thank you for also participating, also for your patience. I know you guys are hungry because it's already at 2 p.m., but I believe you're hungry, but keep satisfied on the side of education. So I wish you a nice day when you get back to school. I wish that you go work hard to practice all the things that you mentored all today. So once again, Mr. Omar, thank you so much on behalf of Mr. Kagwara.